This is the last lesson of Unit 4, and in it you're going to learn more about lines of regression, best fitting curves, and R-values. Just as a warm-up, look at the data that's graphed on this scatter plot graph on car weight with miles per gallon. So as what it's showing me is as the if miles per gallon is higher, the car weight is lower. So here's the car weight. I don't know what measurement this is, maybe tons, I don't know. And how many miles per gallon the vehicle gets. And so it makes sense that as the vehicle's weight increases, the miles per gallon decreases. So when I look at that, it kind of looks like I could draw a line sort of like that. So it would be a linear equation with a negative correlation. This scatter plot graph compares the relative risk of accident based on alcohol level, blood alcohol level. And if I look at the data, it looks like it's sort of half of a U, like a quadratic. So given the choice of linear, quadratic, absolute value, or none, I would choose the quadratic. And it looks like it has a positive correlation. So as blood alcohol level goes up, so does the risk. Okay, this scatter plot graph compares the height in inches of boys on their 4th birthday based on their birth month. And the plots of the graph are all over the place. So there's really no correlation. So there is no family and there is no correlation. It's just random. Well, your calculator is going to help you do things a little more specific than what we just did. Here's some of the vocab you're going to need to know. Data is just the facts and statistics gathered so that we can analyze it. A scatter plot are examples of what you just saw, but basically you're just taking the data and you're plotting points on a two variable axis, and you're looking for the pattern that results to see if there's any correlation present. And then if there is a correlation present, you can find that line of regression or curve of best fit. And we'll be using our calculator to find equations that show the relationship between the two variables. You should have already completed your calculator tour. So you should know where your Stat button is, how to get to Stat Edit, Stat Calc. We're going to be using the linear regression under there, the quad. Also, number 6 is the cubic one, and number 7 is the quartic. And we'll be using all 4 of those regressions. You need to be sure that diagnostics is on. So to do that again, you need to hit second 0, which takes you to your catalog. If that's not on, to proceed with this lesson, you need to pause and get that turned on. You also need to have stat plot on along with scatter plot. If you don't have that on, you need to pause the video and get that turned on. You also need to make sure that your lists are clear under your edit button. So be sure that's done, and also there are no equations under y equals. So clear both of those areas before proceeding. Okay, so just a little glimpse at scatter plots and the most likely equation that would go with these. So just look at these individual. If you look at the first one, number 1, I'm looking at this and I'm seeing that my end behaviors kind of go up, up, and it's sort of U-shaped. So that makes me know that this is going to be an even degreed polynomial with a lead coefficient that's positive. And when I look at my choices, A would be the best choice because it is an even degreed and it has a lead coefficient that's positive. When I look at number 2, I see that my data kind of follows a line, so it looks linear, and it looks like it has a positive slope. When I look at my choices, I see that choice C has a positive slope, and it's linear because the degree is 1. Graph number 3 is U-shaped, has end behavior going in the same direction, so I know it's going to be an even-degreed polynomial. But this time, since it's going down, the end behaviors are going to negative infinity. I know my lead coefficient is going to be negative. When I look CD, I notice that it meets those requirements. It is even-degreed, and it has a negative lead coefficient. By default, I'm assuming that this will be B, and I can tell that it is because it's linear, which B is because it has a degree of 1, and it has a negative lead coefficient. I've already mentioned R values, but I haven't defined it yet. The R value basically measures the tightness that the data fits to a graph. And the closer it is to 1, or really negative 1, the better the fit to the data. It means the tighter it falls to that line or that curve. And you kind of grade it as being either strong, moderate, weak, or none by these little categories. So if it's between 0.7 and 1, it's strong, all the way down to between 0 and 0.1, it would be none. So the closer R is to 1, the tighter or more closely related the data is. So number 1, if the R value, which you'll find on your calculator, is 0.51327, we would say that it has a moderate correlation. For number 2, that one would be none, because it's so low, and 3 would be strong because it falls into that 0.7 to 1 category. Okay, let's try one. If you put this data under L1 and L2 in your calculator, using the Stat Edit button, and then hit Zoom 9, you should see this graph on your calculator. So pause the video, enter all the data, and make sure your graph looks like that. Okay, then once you've got your graph looking right, go to Stat Calc 4, and when you hit 4, you'll see that the linear regression, all of these numbers will pop up. Okay, this is a linear equation. You can see y equals ax plus b. And then it gives us the values for a and for b. It gives me an r squared value and an r value. Notice that the quadratic regression one, which would be under number 5, if you go back to Stat Calc and hit 5, does not give you the r value, but it gives you an r squared value. Well, you need to be sure that you're comparing r squared to r squared, not an r to an r squared. When I compare these two numbers, I see that the r squared value is higher. We're going to look at the first 3 decimal places. So the r squared value for this one is 0.232, and over here it's 0.211. So I know that if I choose a quadratic equation, it will best fit the data that I had. So this is the one that I'm choosing. Actually, this one should be 5 because we chose the quadratic one. So what is the type of correlation? It is quadratic. In my equation, I can see the basis of my equation is right here. So it's going to be y equals, and my a value is 0.087 x squared minus 3.238x plus 121.799. And I'm getting all of this, all of these numbers. So this is ax squared plus bx plus c. And here's my a, my b, and my c. And I just put those numbers in. Now, to get the r value, notice we're asked for the r value, not the r squared. So the r value, you're going to have to take this r squared. So you're going to have to find the square root of 0.3232. And when you do that, you'll see that that's somewhere around 0.482. And so that means that the data is moderately a moderate correlation. So use the equation that you did right up here to find what y would be when x is 25. So what you're going to do is you're just going to put 25 into this equation. So pause your video and do that. And here's the answer, 95.224. Okay, let's try another one. Given the following table, find the curve of best fit. State the correlation coefficient to the nearest thousandth. So pause the video, enter the data, look at the linear regression, the quadratic, the cubic, and the quartic, and figure out which one you think is best. Find the R value and the curve of best fit, and then start the video again to have some discussion on it and see the answers. When I put the data in, this is the graph that I got. I noticed right away that this is not a linear equation, and in fact to me, I haven't looked at my values yet, but it looks like it's probably going to be a quartic. When I compare my values, I get an r squared, and all of them give r squared, so I'm going to compare that. R squared is 0.809. That's pretty good. It's even better with the cubic. And notice on the quartic that there's an arrow, and so that means you have to toggle down and you'll get your r squared value. And look how close that is to 1. So we know that this will be a quartic function. Okay, so the type of curve is quartic. My correlation, or r value, I'm going to have to take the square root of 0.999. And the correlation value, the r value, is still very close to 1. So for my curve of best fit, I'm going to be following this equation right here and plugging my values in. So y equals, the a value is negative 0.767 x to the fourth plus 2.350 x to the third plus 4.680 x squared minus 6.753x plus 0.824. And there I have my entire equation. This ends the lesson, and so you need to complete any problems that are additional in your note pack and bring them to class for discussion.